Okay, there is our neutralization reaction. We need to have an acid. How do we know that we have an acid? We have an H something. Oh, there's another option. What else could we have? We could have COOH. Okay, those are the important hydrogens here and here. Okay, what is our base? Something OH. Okay, then we get a salt and we get water, and I'm going to encourage you to write your water as HOH because it makes balancing easier. Okay, because you have an H here and you have an OH here. That means you can balance your H's separate from your OH's, and it just makes your life a little easier. Okay, so let's try a couple of these. We have sulfuric acid. If you have ick, what kind of ion is that? I ate something icky, so that's sulfate, which is SO4 2 minus. We're going to put that together with hydrogen, which is H plus. That means we need 2 hydrogens, so it's going to be H2SO4. It was completely neutralized by aluminum hydroxide. Aluminum is 3 plus. Hydroxide is -1. So that's going to be AlOH3. Okay. Now, neutralization is just a special type of double replacement. And when we predicted the products of double replacement, what did we combine? We combined the outside ions and the inside ions. So again, we're going to do the outside ions. So we're going to have our H plus and our OH minus. We're going to combine those. So that's going to give us HOH. And I'm going to make them different colors just so you can see. All right, and then we're going to combine our inside ions. We have Al, which is 3 plus. We have SO4, which is 2 minus. Who should go first in the compound? Aluminum, because it is the positive ion. And so that is going to be Al2SO4 3. Okay, Al2SO4 3. And now we balance it, and we balance it very much like we did double replacement reactions. Find the one that is the compound that is the most complicated. Who's the most complicated compound here? Al2SO4 3. So let's grab 2 aluminums and put a 2 here. So now we have 2 aluminums. We have 3 sulfates, so let's put a 3 here. That gives us 3 sulfate. Now we have, whoops, that went away. We have 3 times 2 is 6 hydrogens. And so over here, we're going to need 6 hydrogens. We also have 2 times 3 is 6 hydroxides. And fortunately, we have 6 hydroxides, and we're all done. Okay? So similar to yesterday. Okay? Would you like another example? Yes? Okay. Carbonic acid. If you don't want examples, you can go ahead and do pages 79 and 80. Okay? Carbonic acid. So carbonic acid is carbonate, which is CO3 2 minus. So the acid, we're going to put an H plus with that. That's going to be H2CO3. Was titrated to completion. I'm betting you don't know what those words are, but does it matter? No, because all you're going to do is you're going to put a plus. Something happened, they were together, NaOH. we will learn what a titration is before the end of the year and actually do a titration experiment, okay? Predicting our products, let's find our outside ions. H plus, OH minus, that gives us HOH. Oh, by the way, when you have HOH, you can leave it like that, or you can rewrite it as H2O. Your choice, okay? I don't mind which one you do, okay? If you like changing it, that's great. If you just want to leave it, that's fine. All right, so we got HOH, and now we're going to combine our inside ions, Na plus and CO3 2 minus. So now we have Na2CO3. Let's balance our sodium. Na, we need 2 of them. That gives us 2 OHs, so let's put a 2 here to give us 2 OHs. And that gives us 2 hydrogen. Oh, luckily over here we have 2 hydrogen, and we are done. Okay? I'm going to change this next question because it's no good. Let's make this HCl. Okay? So we are going to predict the products of this reaction, and we're going to predict the states of the products. This is going to be an optional thing that you can do, enriched. Yes? Okay. When it comes to double replacement, you will need to write the states, okay? Because you can't tell whether you get a reaction or no reaction unless you have the states. Here, you are always going to get a reaction when you have an acid and a base because you are always producing water, which is a liquid, which is a new substance. You don't have to be like, do I get a precipitate to get a new substance? Because you already have a new substance. Water is a new substance, okay? So let's combine our ions. Here we have H and we have OH, HOH. We have Ba and we have Cl. So that's going to be BaCl2. And I would like you to predict the state of HOH. It's water, so it is a liquid. Okay, so never worry about that one. That's going to be a liquid. And BaCl2, you're going to check on your data sheet. Okay, we've got, man, I've made a mess of this, haven't I? Okay, so we have Cl. Barium is not in here. That means barium must be up in the all others, which means it is soluble, which means it is aqueous. Okay, so this would be aqueous. Yes. Liquid means melted. Okay? And aqueous is dissolved in water. Okay? So water is melted ice, right? Whereas barium chloride is not melted barium chloride. It means we put it in water and dissolved it. Good question. I like that question. Now, I'm just going to let you know that sometimes Ms. Spence will give you a reactant that is low solubility. And she will say that it is aqueous. And you just have to believe me. Okay, the short answer is you just have to take my word that it can be aqueous, but you will never go against the blue sheet. Okay, that's the short answer. Take my word for it. The long answer, okay, the long answer is that if we look at our data sheet here, you'll notice that it says low solubility. It does not say no solubility. It's low solubility, not no solubility. When something is listed here as soluble, it means you can make a solution of 0.1 moles per liter minimum. You can make at least that. You could maybe make 0.2 molar or 6 molar or whatever. Question? How do we know that HOH is liquid? Because it's water. That's really it. Yeah. Okay. So just remember HOH is water. And then you're like, oh yeah, water's a liquid. Yeah. Now, if it says low solubility, that means I cannot make 0.1 molar, but maybe I could make 0.01 mole per liter. Okay, so that doesn't mean that it's never in solution. It just means that if you're predicting it, we're going to say you need to make a minimum of this concentration. Just use the blue sheet to predict. Okay, but if I tell you something is aqueous and you're like, but Miss Spence, it says it's a solid, just believe me that it's aqueous under those circumstances. Maybe I've made a very dilute concentration. Okay, so let's go back here. Just go with it. Okay, just go with it. That's the short answer. Just go with it. That's it. So you guys are going to try some of the exercises on page 79 and 80. Okay, we're going to get through this and 2 other things today. So let's move quickly. Let's not lollygag. Let's not dilly-dally. Yes.
So, I know when this last time a base, like recognizing these ones, right?
Yep.
I know base it's like OH.
Yes.
And then acid is like H.
H. Yeah.
And then salt is special as anything.
Salt is just any ionic compound that's not a base.
That doesn't and is not acid, right?
Yeah.
So salt can't have OH or H.
That's right.
So basically, if when we're identifying them, if we see we have OH, and then something that doesn't have either of those, and just H2O, then we know it's neutralization. Yeah. Oh, okay. Oh, what about combustion?
We're going to be doing that next.
Oh, okay.
Okay. Yeah. So I was thinking of making it on Tuesday, next Tuesday. Or Thursday. Thursday. Okay, Thursday. Test on this is next Thursday. Yes. Is anyone writing any provincial assessments? It's your birthday? Well, happy birthday. What a nice present for you. Aren't you lucky? You should have been clever like me. I had my birthday in the summer. Wasn't I clever? So now I never had a test on my birthday. No. Which is more important than organics. Because anything you will do, you're gonna need. So, you know, organic. So if you can find, I mean, there's something you say. Once you're right, and it's not hard. Hard organic. Right, mostly all we do. This is a huge number. Oh, look, it's easy to say carbox or well. And you're going to add so honey's no, because grade 12 is all
Why did you put your son for this?
Yes.
That's like I go to the every single thing in this set, right?
Like this is right? This is like the we are learning in a week session. Yeah. Yes. Yep. Yep. That's fine. Hang on. Yeah. Oh, no, it's just part of that's part of each portal. Yeah. Rest of all the documents. So just write H2O. Just write H2O and then forget it. Point. Okay. In here somewhere.
But then it's plus organic.
Two of those out here.
CO2.
Oh.
And then H2O.
Yes.
Collect the balance.
Yes, yes, you're right.
What are you talking?
Yes. 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 Yeah, exactly. Yes.
Two.
CH2O.
You were a fool. Cause like, why do you, okay.
Folks,
Or oxygen.
for combustion, do not write water as HOH. It will not help you. Okay? There are no hydroxide ions.
And on this side.
Even alcohols are not hydroxide. There's something else. Okay, so don't write HOH in combustion. Only for neutralization. I mean, that's how they got that. That's how they got alcohol in the first places. They just noticed a fruit. You can leave out fruit and it will ferment. Yes. Yeah, that's your stuff. Yeah, just page 87. Yes. Okay. 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 So we go on to double the final remember. Okay. So you're going to double your hydrocarbon. All right. You're going to say now I have 8 hydrogens. Right for there. Okay, and now I have 4 plus 2 is 6. These will be there. Yes, yes, yes. Yes. Okay, so what can you do?
20 oxygen. That's 11 oxygen. And it's 31, so then that's 31 over 2. Then 31 over 2 over 2. Wait, shit. Wait,
Okay, so actually, I did.
so that's going to be 15, right? Yeah.
So that's 8 plus 6.
16.
Should have been 14.
H2 plus 15
Yeah.
over 2
I messed up.
is
Methanol.
CO2
Methanol.
plus 11H.
There's the room.
C. There's 10 C's. 10 C's.
Methanol.
Was it? Was that 22? Not 2. 22
So you just say
H's.
CH3OH.
And then 22 H's. And then there's 1 O here and 30 O's here. So that's 31 O's here. And then that's 20 O here. And 1 O.
Look at reactants. Look at the reactant. Plus. Yeah.
Okay, so then that's 31 over 2, like 4.
Yeah.
So then
Once
you
again.
gotta multiply 2 CO10 H 30.
Yeah. Yes.
I'm not sure the answer. Let's do 31 over 2. Not 30 of them.
Some firms will take oxygen. All the firms will some oxygen. So I think it's other oxygens. Imagine there's a fire and you broke apart all the atoms and now we're sticking them back together. Yeah. Yeah. Just 1 second. Yeah, no. Your products are always CO2 and always.
No. Initially, I was on the right track. I didn't know you had to add an O, and then you said something, and then I added an O.
There is no.
Exactly. So like,
Yeah.
like in the beginning, I didn't know an O. But then,
So what you're gonna do is actually unbalance. If I have an even number and an odd number, I'm gonna find the even number is like 2 odd numbers are 1 3 okay? So your even numbers is visible, right?
and it,
Odd numbers. Okay, so I have an odd number and an even number, okay? And I can find the lowest common multiple. They both multiply into 6.
I thought it was gonna.
So I'm gonna try and get 6 of these, 6 of these, so I'm gonna put 2 in front here.
I thought that complied with the previous.
No, I'm not putting 2 there, I'm bringing 2 there, so that. Just right in there. Okay, so now, I'm just gonna need 6 on.
Shut up. Shut up.
Yes. Yeah, it's multiplying.
Oh, you did say
Yes.
okay.
Okay, and then, we also need to have 6 oxygen here. So we'll just put it right there.
Oh, you're right. I don't know. Okay, let's choose here and you can choose.
Yes, and you do the same number of these. You iron, yeah, that's where you're oxygen.
Your head was just
You have 6 oxygen here.
My apologies. I would have looked at
You have 6.
I wasn't there.
Oh, 3. Yes.
Yeah, I had 3 here.
No, what I'm doing
So you
here,
said on.
because you're multiplying it in front of the oxygen. And then, 2 times 2 is 4. 4 there. Yeah. Okay. We have a question back here. Figured it out. Do you want one of these? Okay, I'm going to one out. Because I ran it. Yeah. I have this sheet though, but. No. It's the same thing. No. Yeah, there's more things, but I'll give you.
Same, it's like,
Yeah.
yeah. Big same, not, just not same.
Balance your own, balance your own.
It's not, doesn't,
Nope.
can.
Always the same, so it's always O2 CO2 H2O. O2 CO2 O2 CO2 H2O, like it's like really, other than like that first thing, it's so
Maybe do
boring.
like a fill in the blanks or something, and I can like fill in the blanks. Okay.
Yeah. Okay. Yeah. Yeah.
Maybe fill in the first three words, cause I.
Okay.
Fill in the big thing. I didn't write an O, and then I wrote an O, and then I took the O back again.
You don't wanna know.
Yes,
It's been all, yeah, no, all, yeah.
Big weird ones. A. A. That's an H.
There's no advantage writing it out.
Okay. Big hole. Wait,
You surviving? Uh-huh. Oh.
I said we should back for the count thingy.
Oh, okay.
What was this? Yeah, workshops. That's what I'm. What? Well, it's 2 plus 8.
Yes. Yeah. Yeah, so if you double your hybrid carbon. Well, you're going to, what you want to up, 16 and 12. So if you always do this, sometimes you have to say, well, check all the time.
Oh, yeah.
Say, are they all 20? If they are, they're not.
Six.
Yeah. No. It's a different. Yeah. Yeah. There's lines. There's lines. There's 20 inches here. 20 inches. After one, there's one hole plus 28 holes. So it's on nine.
Okay, so now we are on page 92. And we're going to do an organic acid and a base because there's something that's a little bit different. Okay, ethanoic acid, that is based on the ethanoate ion. Okay, and ethanoate is CH3COO minus. Now we don't write the hydrogen at the beginning. We write the hydrogen CH3COOH. So that H plus actually gets put on the end. And we are reacting it with calcium hydroxide, CaOH2. Now we're going to run into problems if we try to do our outside ions and our inside ions, because let's look at our ions. We have CH3COO minus, and we have H plus. We have Ca2 plus, and we have OH minus. What would happen if we put our outside ions together? Does that work? Can you put a negative with a negative? No. Okay, negative does not go with negative. Negative only goes with positive. Therefore, you must use your brain and say, I need to put my positive with my negative. And the other thing is, you know that hydrogen is always going to get together with hydroxide, right? So one of our products is going to be H2O. Or actually, we can write it as HOH. Hello. What's up?
Appreciate this, people. That red line for the hydrogen to the hydroxide, we gotta straight that line in.
Woo! Okay. Teachers need to get a life. I understand. Okay. So now we have this H here. Okay. And we have Ca is going to go with the COO negative. And so that's going to be Ca CH3 COO2. All right, and then balancing, we need 2 acetates, so let's put a 2 here. We need 2 hydrogens, so let's put a 2 here, and that balances it. Okay? So you will also be given a chart that lists all of the organic acids. So you do not need to learn how to predict the formula for them. If you want to, that's what's back on pages, 88, 89, 90, all that stuff, okay? But you don't need to. So if I was to say to you, we have propanoic acid, and you'll be given the formula CH3, CH2, COOH. Which of those many hydrogens is the acidic hydrogen, is the H plus. The H at the end. That is our acidic hydrogen. That is the one that becomes H plus, which means that our negative ion is going to be CH3, CH2, COO minus, because whatever is not the positive ion has to be the negative ion. Okay, so I know it's big, I know it's long, but that's what it is. And then, of course, you might have it plus LiOH. So you would then have Li plus and OH minus. And again, you need to be sensible. Don't just randomly combine the outside ions with the inside ions here, because then you'll end up with two negatives together. Who should go together? Lithium should go with this big long thing. Yes? So we would have Li, CH3, CH2, COO, and then hydrogen gets together with hydroxides and we get H2O. Okay? And that's it. So you can try some of pages 92 to 93. This? Yeah, they would be in my. Yeah, it's not our general panel. It says. No, there's no advantage because even in that looks like noise, it's not an ion because it's on the voltage. So it's not.
Yeah, you left home at 10 a.m. that day. And it's going to be July, and you stayed there. And then she goes, I and then it took us like half an hour to get.